Last semester we talked about proving triangles congruent by things like side congruence, or side angle side. Remember that? Angle side angle, angle side, hypotenuse leg, and that's one way to prove shapes congruent. After doing transformations, you can also prove that they're congruent by finding a transformation that maps one shape exactly over the top of the other. So if you can describe like a rotation or a translation or reflection that places the original shape right over the top of the other so all the points match up, then that's another way of proving two shapes are congruent. So there is one proof in tonight's homework, but I don't want you to do a two-column proof. All that you're going to do to prove it is tell me, explain in words or in symbols, what transformation would take one shape and match it up with the other. Okay? So it's like, it'll be maybe one sentence proof. Okay? So we're looking at proving shapes are congruent. For example here, example 1, we've got two different pairs of figures. I think it's pretty obvious. These are congruent to each other. So I can say A, B, C, D, that's parallelogram A, B, C, D, is congruent to H, I, J, K, parallelogram H, I, J, K. And if you just look at your note packet, can you tell me which transformation would take this one up here, and map it down to this one? Let's go this direction. So look at it. It is a translation. Let's practice using our symbols since we're kind of still getting used to that. So it's T, and then I'm going to use these little thingies here, less than, greater than symbols. Translation, so if it's a translation, then that means every point is moving the same distance right and the same distance down. And I would agree with you on that. So let's just pick one point, say C. And I'm going to go and see how far over and down it has to go to land at its corresponding point J. So it looks like 1, 2, 3, 4, 5, 6 right. So I put a 6 in here. Is that clear? 6 for going 6 right. And 1, 2, 3, 4, 5 down. So I put a -5 in here. And just to verify that, you might want to pick at least one other point here, like D. To go from D to K, is it the same? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. It looks like it. And all throughout the shape, it would be 6 right and 5 down to land exactly on its corresponding point. So you're right. Translation will do it. So we can prove two shapes are congruent by describing the transformation that maps one figure onto the other. This one is a combination. This is a composition to go from the triangle to this triangle. Can you tell me carefully which two triangles are congruent here? You may have to look at it for just a moment first. I'm going to start with triangle. I'll start with the left-hand side. I'm going to say triangle UVW. So I'm deciding the order based on starting with triangle UVW. What would it be congruent to? M?
N.
Okay, so UVW. It looks like U and V and W are the two congruent sides of an isosceles triangle. I believe it is isosceles because if I go over 1 and up 3, and over 3 and down 1, looks like by the Pythagorean theorem the side lengths would be the same. So UV looks like it would correspond to MN. So I should have MN first and then Q, just based on the way that I named it, right? I'm going UVW and it looks like MNQ. So what looks like is happening here in terms of matching these up? And there's more than one way to describe it. It could be a rotation, yeah. That was initially what I saw. It would actually be a rotation in the opposite direction that we normally do, maybe clockwise. I couldn't quite figure out. I would agree there could be a rotation. I think there's an easier one here. Not as obvious. I saw a slide and then a reflection, yeah, over the x-axis is one that will work. Let's just check that here. If I take and slide, so U has to match up with, let's see, UVW. I didn't name the triangle right here. UVW. Looks different from what I had before. So UVW, VW, and Yeah, last time I did this, if that's true, then W would have to, I think, go with M if I reflect it. I had a slide over to here, and then a reflection. If that was a reflection, then Q would go with U. And I didn't name it right here. So UVW, it would be Q and M then is what I have. So if we're going to go with what I was thinking, and this isn't the only way to do it, it would have to actually be the U would correspond. If I slide it over and then flip it, the W needs to go with the M. You see what I'm saying? I think I can demonstrate this better. So the M would go with the W, and then the U is going to go with the slide it over, flip it over. It's going to go with the Q. And then the V, if I slide it over and flip it over, slide it, flip it over, V should go with the N. Actually, Q and let's see. It should be Q and M. Is the way I did it. Let's try it. See if that works. So triangle UVW. My idea was to go ahead and move it 1, 2, 3, 4, 5, 6 over. So my new U would be here. That'd be U prime. And then 1, 2, 3, 4, 5, 6 over. There's my V prime, and then 1, 2, 3, 4, 5, 6 over. There's my W prime. So there's my shape after translating it. And then I'm going to reflect it over the x-axis. I believe that works. 1, 2, 3, 4, 1, 2, 3, 4, 1, 1, 1, 2, 3, 1, 2, 3. You see it? You see it now, the slide and then the reflection. So how would I use correct notation on that? We did the translation first. So it would be a composition. We'd have a reflection over x-axis composed with a translation of -6, 0 of triangle UVW. At least that's the one I saw. Now I'm not saying that's the only way. There are other ways to do it. The rotation could probably work. I didn't, I saw it looked like it could be a rotation, but it wasn't going the rotation that we normally go. But if you can see it here, slide, that's what this is, 6 units left, 0 up or down, and then flip it over. And you've got it. Okay, don't back up yet, I got 2 more minutes. And then we describe it. If you can describe it in words, that's fine on this. Okay, if you want to just describe it in words, but you will need to know the notation when I go the other direction. If I give you the notation, you need to be able to do what it says. Okay, but that's okay to write it in words. Okay. What about this one right here? I think I have the same thing going on here. That's probably why I was thinking there. What is the transformation that takes triangle NAV to BCY? I think this is another slide and then flip. Yeah. So we could just describe it as a translation and reflection.
Yeah.
Let's see if we can get specific. What is the translation? Does it look like? If I want to have NAVC, V needs to correspond to Y. So I've got to move V all the way over here. 1, 2, 3, 4, 5 over. And then I think I can flip it. So it would be a reflection over the x-axis. That's why I was thinking reflection. Composed with a translation of, is that going to work? 1, 2, 3, 4, 5 units. 1, 2, 3, 4, 5 units. Yep. So translation of -5, 0 of triangle NAV.
Report to the attendance office.
And that's it. So if you can describe, now this is not the only way. Okay, there are other answers that'll work in terms of rotations and slides and things like that. But your goal, guys, is to explain some kind of transformation in words or symbols to make it match up. Okay, the corresponding part.